Humankind is heating up the planet. In nature, volcanoes can create cooling blankets. Should we copy something like that artificially and cool the climate with technology? On land, in the oceans and in the atmosphere?
An emergency operation for our Earth's climate. The closer we look, the more problems we see. We have to reduce the carbon dioxide in the atmosphere. You can't do that locally, that has to be global.
The Earth as a big lab, an opportunity or a risk? Global warming as a nightmare. That's what the Danish government said in 2009 in the run-up to its climate summit. Oceanographer Andreas Oschlies doesn't believe it'll be quite so extreme. Nevertheless, a number of scientists share the sense of alarm. They're suggesting artificial interventions to cool the climate. Such targeted climate manipulation is called climate or geoengineering. Andreas Oschlies coordinates a climate engineering evaluation program run by the German Research Foundation. His employer, the GEOMAR Helmholtz Centre for Ocean Research in Kiel, is also involved. The elaborate technology for use on research ships is ready in the logistics hall. The goal is to collect data for better climate simulations because the ideas that have been developed are far-reaching.
We basically have two big groups of ideas when it comes to climate engineering. There's the idea of reflecting some of the incoming solar radiation back to space before it can cause global warming. That would address one symptom of climate change. The second category of ideas focuses on filtering out the carbon dioxide, the greenhouse gas that's currently causing warming. You take carbon dioxide out of the atmosphere and store it in biomass or in the ocean where it no longer has an active impact on our climate.
Most climate manipulation ideas are only in the design stage. However, there have already been some experiments in the ocean. The research ship Polarstern, for example, has conducted testing in the Southern Ocean. It found a huge echo among politicians and in the media 6 years ago. A controversial mission because iron sulfate was released as a fertilizer for algae. It was pre-mixed with water on board and then fed into the ocean. 6 tons of iron sulfate, the kind available for sale in garden centers as lawn fertilizer, was released into the oceans in a diluted form. The idea was to trigger algal blooming. A larger number of algae would remove a greater amount of carbon dioxide, a harmful greenhouse gas, from the atmosphere. When the dying algae then sink to the bottom of the ocean, the carbon dioxide no longer has any impact on the climate. The algae certainly did increase rapidly, but so too did the tiny animals that feed on them. They reproduced more quickly as a result of the additional food. The evaluation showed a great increase in the number of copepods, a kind of crustacean. Instead of dropping to the ocean floor, the algae entered the food chain. That was a surprise. It might not have happened with diatom algae that exist in other locations in the oceans. Copepods don't like their hard shells.
It's like in the garden. In some places the fertilizer works really well, in others it doesn't, because something else entirely is limiting growth. We see that in the oceans. There are mechanisms we have to understand better in order to be able to make better forecasts.
The computer predictions and models can only be as good as the information that's fed into them. And there's a further hurdle. The vast dimensions. The quantities needed even for a small impact are unimaginable.
You'd have to fertilize the entire Southern Ocean. You'd be shifting ecosystems. You'd be making huge interventions, changing a vast part of the planet just to capture 10% of our emissions. Is it worth it? Do we want that? Or can we find simpler ways of reducing our carbon emissions without globally manipulating entire ecosystems?
So iron sulfate fertilization has taken a knock for the time being, but the trips undertaken by research ships are proceeding full steam ahead. They use elaborate technology to ensure that we understand the mechanisms better. The scientists from the GEOMAR Ocean Research Centre are hunting for more valuable data. They're using a new kind of measuring robot that glides through the oceans with minimal energy use. The depth and route are set remotely via satellite. That's also how the data arrives in the headquarters in Kiel. The center has more than 10 such devices. In addition to the standard research program, they can also examine unusual changes in the ocean more closely.
How can we assess whether something's a natural change or whether it's a change that was caused by human intervention? Maybe we believe there was some manipulation, or that some process could suddenly change dramatically. And then we approach the matter in a targeted manner with these robots and measure what's going on in the water.
It's not just the water that counts. The land, along with its vegetation, and the atmosphere are two other Earth systems that influence each other in a wide variety of ways. Every one of these systems contributes to global warming and could help reduce it. Scientists from different disciplines have to share their knowledge and discuss potential effects of large-scale interventions. How far should they go? How far can they be allowed to go? Important questions that are being asked at the Climate Engineering Symposium in Berlin. 16 universities and institutes are participating in the German Research Foundation's program. The core question is, what are the opportunities and risks of the various approaches? A lot of food for discussions about reducing the ocean's acidity content, or about introducing minute particles high up in the atmosphere, or about irrigating deserts and planting trees. Experts from other countries have also come. From the United States, for example. The German professor Klaus Lackner has lived there for many years. He's a renowned expert on removing carbon dioxide from the air. Spraying sulfur particles, acid, into the upper layers of the atmosphere is more controversial. The eruption of the Pinatubo volcano in 1991 has shown what far-reaching consequences that can have.
We have the natural example of volcanic eruptions, where a lot of material, rocks and a lot of sulfur, is flung high up into the atmosphere. That caused a layer of dust that could be monitored in the atmosphere for a few years, and it also led to a cooling of the Earth for a few years. That means we've seen it work in nature, but we can't trigger volcanic eruptions, and nobody wants that. Instead, the idea is to deliver the dust directly high into the atmosphere. We don't know in practice whether that would work. If we were to spray sulfuric acid, for example, what would the particles have to look like to do this in the most efficient manner? We don't know all the side effects.
That's part of why geo and climate engineering have attracted the attention of concerned citizens. Demonstrations like this one in Berlin are happening in many countries on Earth. One of the many substances they're worried about is sulfur. But the other ideas also met with resistance.
Another idea is to generate more and whiter clouds that reflect a large part of the incoming solar radiation before it can cause warming.
Entire fleets of ships would have to whirl up salt water constantly to produce more white clouds that then act like a parasol. The reflection of sunlight is one approach. A fundamentally different one starts right with the harmful greenhouse gas, carbon dioxide. The idea is to remove it from the air and dispose of it. Klaus Lackner and Alan Wright run such a procedure in Arizona. It's called direct air capture. The technology is supposed to do what plants do in nature, just much more effectively. That's harder than it sounds. He's been researching the method for many years now. Even though there have recently been a number of successes, the scientists still have a lot of work to do. The many laboratories at Arizona State University are overflowing with technology. This intellectual smithy, where the technologies of the future are being developed, is located in Phoenix, Arizona, a city of 1.5 million people on a plain surrounded by mountains. Lackner's latest device will have to cope with the hot climate on the university roof. The lamellas contain a carbon-hungry artificial resin around which air circulates.
This machine absorbs almost 1,000 times as much carbon dioxide as a tree with the same effective cross-section which the wind blows through. The reason is that this is a specialist. Its only job is to collect carbon dioxide. That's why it's much better at that than a tree, which also has to live and photosynthesize and all these other things, which get in the way if you just want to collect carbon dioxide. We're a bit like a tractor pulling a plough. We're better than a horse, but a horse can do it too.
Even when the effectiveness is increased 1,000-fold in light of the additional gigatons of carbon dioxide that are influencing our climate, it seems like a Herculean labor.
We don't want to achieve the dimensions that we need in order to have an effect on the climate by building very few, very large machines. Instead, we want to build a vast number of small machines, millions or hundreds of millions of them. A bit larger than this one, but they ultimately have to fit on a lorry and be carried to their destination.
The large number doesn't bother Klaus Lackner. His argument is that we can build 80 million cars per year too. At the moment, the procedure is still too expensive, but it's constantly being improved. The shapes covered in the artificial resin are being made more and more efficient. This is how it started 10 years ago.
We thought of it as analogous to a tree. We thought it looked a bit like a conifer. We have it as a design now. You can put them together. You can put 10 in a row or 20. And we could make an entire mattress out of it. And this is the air filter for the larger device we're building. The idea is that in 1 or 2 years' time, we'll have boxes that constitute the air filters, but they'll contain the individual modules that can then be mass-produced from these little things.
The carbon dioxide removed from the atmosphere would have to be removed safely in vast quantities for centuries.
The carbon dioxide is moved to a factory and you have to decide what to do with it. Do you pump it into the earth or the ocean? Those are the big questions that haven't been solved properly yet, technically or socially. Who wants to have that much carbon dioxide?
Lackner has a goal here too, oil and gas companies would have to take back and dispose of the carbon dioxide. Biosphere 2 is an hour's drive from Phoenix. In the 90s, a group of scientists spent 2 years living here, completely isolated from the outside world. It was meant to be an insulated climate capsule with functioning cycles. But oxygen, carbon dioxide and much more got out of kilter. The experiment failed back then. Now the University of Arizona uses and funds the complex. Klaus Lackner and Ellen Wright are welcomed by Till Volkmann, a hydrologist from Bremen, Germany. They've been invited to look at the latest experiment in more detail. Artificial soil slopes have been created in 3 complexes. At the moment, they've not yet been subjected to anything. But soon, they'll be exposed to different influences so the scientists can compare the results. It's a landscape evolution observatory.
Each of these slopes measures 330 square meters, and they're 1 meter deep with ground-up volcanic rock. This rock represents a relatively young surface of the Earth.
The scientists are hoping to get new, fundamental insights from the wealth of data. The different climate situations can develop their impact over years.
We're able to introduce a temperature increase, the kind we're expecting for the Earth in the coming century. We're able to introduce higher carbon dioxide concentrations and see how and in what direction this entire interacting system develops and interacts with the climate it fuels. This experiment is one of the largest Earth science experiments of all time, where we can really control the climate. It's a great honor for me to be part of it. It's very inspiring.
Thousands of probes and sensors have been installed in the ground. This climate experiment has taken a lot of elaborate planning. Steel companies, earthworks, spray and measuring sensors, years of construction in time-lapse. The available space isn't being fully used yet. Other experiments have been ongoing in the biosphere for years. The guests from Phoenix worked here themselves for a while. They're familiar with some of the research. Everything's insulated from the outside world. That makes the experiments less complicated. Carbon dioxide quantities play an important role in the mini-ocean as well as in the savanna. Installed below the surface are kilometers of corridors and pipes. The insulated environment requires a lot of technology to survive. There's even a rainforest here. The facility only has partial systems for experimental purposes, but they're already a challenge for the scientists.
My experience in dealing with the work here at the Biosphere is that the larger the scale of the experiment, the more difficult it is to separate out all the variables that might have an impact. So I think you have to be very careful when you do large-scale experiments that you understand exactly what it is you're trying to find out.
It's a much smaller, simpler system than the real world out there, but it's nevertheless already so complicated that we can't really predict anymore what it will say.
It won't get any easier out there in the real world. Climate engineering on the global scale. Risks, international agreements, liabilities. These aspects are as yet all unanswered.
Es kann ja sein, dass irgendwas
It could be that something at some point will work quite well, but it at least has to happen in a responsible manner. We have to have clear regulations about how such experiments can be conducted. Who has to decide? Who has to agree? We'd all be test subjects if someone started doing manipulations in the Earth's system, because it's a cross-border issue. If something's manipulated in one area, it'll have global consequences. We've said in Germany that we definitely won't do these experiments. We can't do them.
However, it is possible to close research gaps. When assessing the biosphere, for example, forests play an ever-increasing role here, and, as Markus Reichstein has found out, so too do soils. Hainich National Park in Thuringia in central Germany. A measuring tower stands more than 40 meters tall, peering out above the treetops. The air is made to eddy by the treetops. The Earth's breathing is determined in the boundary layer, as it were. Carbon dioxide content, humidity, and the exchange of gases are measured and compared with other stations. There are more than 500 around the world.
This method allowed us to quantify for the first time how much carbon dioxide is taken up by the vegetation through photosynthesis and how much is released through breathing and how much water evaporates. Before, we only had theoretical calculations and no actual observations.
This allows us to see more closely how the Earth breathes, in other words, how the carbon dioxide exchange varies over the course of the year. What's surprising is that even savannas, with only a few groves and a dense layer of grass, absorb a lot of carbon dioxide. More carbon dioxide in the atmosphere fuels climate change further. Weather events such as droughts can occur more often, which in turn has an impact on vegetation. The influence of soils was underestimated for a long time. That's now going to change thanks to regular soil samples. They're elaborately analyzed in the laboratory of the Institute in Jena.
This data has shown us phenomena that we can't even describe with our current Earth system models, such as the effect of extreme climate events on the vegetation and the soils.
One such effect is that an arid summer can release as much carbon dioxide in one go as the soil has stored up over the past 5 years. Lauren Fletcher sees enormous potential in planting trees. The former NASA scientist walks past historic technology in the London Science Museum to get to the Innovation Department. His award-winning project is on display in a special exhibition. These objects don't look like trees. His unusual idea starts way before that.
Well, I know. So the seed of this idea, pun intended, came actually from a science fiction book I read like decades ago. And in this science fiction book, which is like 1,100 pages long, there's a single line in it that talks about machine gun planting a quadrillion trees. And I said, a tree gun, that's so cool. Who wouldn't want that?
It's not science fiction anymore.
3, 2, 1.
Now there's a startup company and a firing apparatus that shoots encapsulated tree saplings into the ground.
Yeah, no, it's really pretty perfect.
The plan is to plant 1 billion trees every year. It's an ambitious goal whose success will depend on drones. Fletcher and his team are developing an ingenious system. First, the scouting drones will scan the intended terrain and determine where planting would be best. The reforestation efforts are supposed to deliver an intact ecosystem, not a monoculture. Then drone fleets will implement the planting schedule.
And then these ones.
The team are meticulously working on the details. The seed shell is crucial. It's filled with a mix of soil, fertilizer and seed and has to be correspondingly versatile.
I've also taken into the idea of, again, just like you would have on sort of... This is complicated and expensive because there's so much material to it. So in our project, in our program, the cost of the drones are not insubstantial, but they're not that expensive overall. The real cost are these. Every time you increase the cost of this by a penny, that is an absolute huge cost when you're planting 1 billion of these a year or 2 billion of these a year. So we have to focus on optimizing the design to protect the seed as the very first priority.
So after 4 or 5 weeks,
How the mix grows and what tree varieties are planted is important too.
they are still coming up.
These test series are looking at fast-growing trees such as eucalyptus, princess trees and custard apple trees.
They grow, actually.
A first planting session could take place in Thailand.
To about 1 meter a year.
As the technology improves, as we are able to work with different soil types, as we are able to work with decompaction of land too, we can basically go everywhere and anywhere. There are plenty of places that needs restoration, and they just don't have enough capacity or enough people to do that work. And that's where we hope drones can fly in and do the job.
Further development is necessary before billions of new trees have been planted. Although it's a good idea in itself to recover lost ecosystems to make a noticeable difference to our climate, we would once again need completely different dimensions.
If we really want to improve the climate or remove a large amount of carbon dioxide from the atmosphere, then we have to reforest entire continents. If we do it on such a large scale in the climate models, then we also have large-scale side effects that are dangerous.
The monsoon rains and other precipitation could change and trigger flooding. On the other hand, previously wet areas could dry out and new deserts could form. These are not good prospects, so what remains?
If the emissions continue the way they have been, then none of the methods we've tested on our computers is potent enough to be able to save the world. We have to reduce carbon emissions to zero, and we have to do that in the next 20 to 30 years.
Every new step is important. Some are easy and entirely without side effects. Measures such as the White Roofs project, for instance. Starting in New York, white roofs have spread all across the United States. Light-colored roofs reflect more sunlight, the land heats up less, and air conditioning units save energy. A view from the roof of the City Hall in Phoenix reveals the roofs here to be predominantly white. The message is that every measure counts, and the more countries get involved, the more effective our efforts to save the climate will be.